Okay, it's recording. Uh, can you see my screen?
Yes, it's visible.
Okay, is the font okay?
Yes, it's okay.
Oh. So the first problem for today will be you've read about testing for proportion, right? So let's try a problem with that. So let's say company X has developed a gadget to do a medical test. It claims that uh, the mm, yeah, it claims that it returns correct results 99% of the time. Okay. Now, to confirm this claim, you decide to do a survey. Okay. So you ask 100 people to take a test with a doctor and with the gadget. You have this data in a CSV. So propose the null and alternate hypotheses, and based on the p-value, comment on the company's claim. So initially, you can try out the library method that you were taught in the class. After this, we will try to do it manually. So let me give you the data. We have week 4 gadget. So see if you can access this. So load this data and do the required pre-processing, and then create two hypotheses and compute the p-value. So uh, let's take 10 minutes. After 5 minutes, if enough people are done, then we'll move ahead. So is the data accessible? Can anyone confirm? Sudha, can you type it in the chat? You have a lot of noise in your audio. Okay. So if anyone is done, please raise your hand. Okay. Is anyone done? Yeah, if anyone is done, please raise your hand. It gives me an idea of how many people are done. Okay, so those who are not done, look for this library. Stats model dot stats dot proportion. In this library, you will have a function proportions z-test. Look this up and see if you can utilize it to answer these questions. Okay, has anyone done it? Okay, so let's start. The idea is to use this function to compute the answer. So first of all, what does the data look like? So we have import pandas as pt. Our data frame will be pt dot read csv. We give it the URL. Let's say give it the URL. We can break it here. And then we say index is sorry, header is 0, dot head. Yeah, so we have this data where we have responses from the doctors and responses from the gadget. So it says that it is correct 99% of the time. To compute how many times I am correct, I can create a new column, that is df correct, and that will be equal to df dot doctor being the same as df dot test. So if I, let's say, print the head after that, I get these values and I can check how many times I am correct. So let's say df dot correct dot sum divided by length of df. It says that I am correct 95% of the time, while as the claim is 99%. So we have to develop two hypotheses, the null hypothesis and the alternate hypothesis. So the null hypothesis is obviously that everything is as expected, that is the gadget works 99% of the time. The alternate hypothesis will be that my gadget performs gives results correct, let's say less or equal to, in our case, let's say 95, actually 99%, now we have 95%, so we have to test against this one. So if we look at this function, it expects these values. The first one is how many times do you get a correct result. Number of objects says how many trials did you conduct. In this case, it will be how many samples are there in your survey. And then it says a value, that is what percentage, basically what is the probability that an individual result will be correct. Okay, so if we want to use this, we'll say what is the name of the function? It says proportion z test, proportion z test, and it takes NOPS. So count in this case will be df dot correct dot sum. Uh, the number of objects will be length of the df, and our value will be the claimed probability. So the claim probability was 99%, so we'll supply 0.99. This will return two things. The first one is the z-score, the second one is the p-value. So we'll write, let's say, z-score, comma, p-value is equal to this thing. Now, based on this p-value, we have to make a decision. So we'll say, let's print these out first. So let's say we have print z-score, p-value. Now, because our z-score is negative, it means that we are on the left side of the mean. So to compare with alpha, we'll say if the z-score, if in fact, if the p-value is less than alpha, we'll say that reject the null hypothesis in favor of the alternate. Otherwise, we'll say we can't reject the null hypothesis. Remember, we were not saying that we'll accept it, we're just saying we can't reject it. So let's set alpha first. We had this, and alpha is set to 0.05. So it says we can't reject this because we have 0.06 and the value is 0.05. Does anyone have any confusion? Okay, so in case you don't have a confusion, what if you did not have this function and you had to do this manually? How will you do that? So take 10 or 15 minutes more and try to do it. You can refer to your class lectures, your slides, and look it up. I mean, how to do this manually. Oh, we actually missed one thing. We supplied alternative to be two-sided by default. This should be one-sided in this case because you see that our z-score is less or equal to 0.95. So we don't need a two-sided thing. We need a one-sided value. So this will be singular, I believe. It says smaller, yeah, smaller. So it would just be half the value of two-sided because it just multiplies it by 2. And if we compare it with this, we get, yeah, this time we can reject it because we are below alpha. So take 15 minutes, try to do it manually. You can refer to your lecture slides. Yeah, let me explain that. Yeah. So let's say, yeah, so the null hypothesis was 99% all the of the time I am correct. My alternate hypothesis that was that because once I loaded the data, I found out that my value was 95%. Now, my alternative hypothesis was that I am below or equal to 0.95. My hypothesis was that I am not equal to 0.95. So let's say, one thing is less or equal to, another thing is not equal to. When your alternative hypothesis is not equal to, you have to consider both sides of the normal distribution, the standard normal distribution. When you're considering either less or equal to, or greater than or equal to, you only consider one side. If you're considering the lower one, then you supply smaller, as we supplied here. If you're considering the other side, for example, let's say this would have been, for example, 50%, and now our data set told us that I am 95% certain that my results are correct. In that case, we would have used greater or equal to. And the third case is, if you are only testing for one specific value, you say not equal to, and then you have to check on both sides. Does that make sense, Pratishtha? Um, so Harshita, you're asking why did we take an alpha value of this? So I mean, it was just for this toy example, I picked it up at random. So it wasn't anything I mean decided. Yeah, I'll repeat it in a second. Yeah. I joined the lecture first time, missed a lot of content. Please let me know how to cover the previous lectures. Um, if you're referring to the online sessions, you can go to YouTube and you'll find the recorded lectures there. In the recorded lectures, what we try to do is, uh, the week's content, whatever you studied in the previous week, we try to develop programming assignments, programming questions around them, and discuss them in here. So you did the formula in Colab, though it is coming out positive. What is coming out positive?
I mean, the Z score is coming positive instead of negative.
Okay, so we'll check. Yeah, we'll check. Okay, so for this part, I think it will be clear after the visualization. So wait for a minute, maybe. The third question will be to visualize this, all of this. So maybe you'll understand it after that. So wait for that. By the way, Ankur, what formula did you use?
Just square root and normal plus minus multiply divide.
Square root? No, I mean, can you explain it? I mean, better.
The normal proportion formula is the z is equal to p hat minus p0 divided by p0, oh, square root of p0 multiply by 1 minus p0 divided by n. So I just use that formula.
So let's say I have, if I know correctly, the z score is given by first, let's say, probability p. For example, yeah, p0, let's say in this case, divided by p0 multiplied by 1 minus p0, and all of this is divided by um, square root of square root of sample size, let's say n, and here we supply the mean. So does this make sense? I think this should result in the correct value. Yeah, this should impact the let's say mu sample, right? Maybe this SQRT should be over the whole thing.
Yes, now it's okay, I guess.
Wait, messed it up. We have this divided by the square root t p0 1 minus p0 whole divided by this thing. Yeah. So is it coming out correct?
Can you show that formula again?
So let me try on my side. Okay, let's see.
Hmm.
So the whole idea of doing it manually is to get to this value, this z score. If we know the z score, we can compute the p value as well. So in case of proportions, the way you compute a z value is you use this formula. That is, you should know the mean of the sample. Mean of the sample in this case will be we can also say just the probability of the correct ones. So let's say df dot correct dot mean. So df dot, I don't think what it will return because these are Boolean values. 0.95, yeah. So we have the means of the sample, we have mean of the population, which in this case will be 99. And then we say, uh, wait, this is mean, yeah, probability, and this will be the same in this case. Okay. So in this case, we will have this. So let's say we have the numerator. Numerator will be mean sample minus the mean of the population. And then for the denominator, we'll use this thing, the probability of 0, which in this case is same as mean of the sample, or actually it will be 95%. So let's also write that. That would actually be the same. Proba 0 is df dot correct dot mean. By the way, this is clear, right? By the mean and the probability are the same in this case. Any confusion here?
No, it's clear.
Okay. So this is again 0.99. So for the denominator, we'll have, let's just keep it P1, P0. So we have P0 multiplied by 1 minus P0. We don't even need this. Yeah. So divided by length of the data frame, and we square root all of this. Square root all of this, we'll have the z score is equal to, we don't have numpy.
It was showing SQRT as in maths library actually.
It should return the same value, right?
Okay.
Let's write z score man so that we don't erase our previous one. So we have z score and z score manual. Same values, okay? Any confusion? Okay, so now that we have the z score, we need the p-value. So p-value in this case, again, let me explain it again. So we are saying that what is the probability that the sample mean, that is mu s, or for example, in this case is probability that x is less or equal to 0.95, given that the hypothesis is correct, which says that I am from a distribution with 0.99 standard deviation and everything. So what we'll do is we'll say from scipy import stats. So stats dot norm loc 0, because we're using z scores, we can use the standard distribution. So we have the standard distribution. From this, we just need the area under the graph up to our z score. So it says 0.33, and I think it is the same value, right? Same values. So we'll just say that p underscore value underscore manual is equal to this thing, and we print p underscore value underscore manual, and we get the values, and we can once again print out the same thing. Okay, so as the third part of the question, can you visualize this thing? What we just calculated, that is p value is less than alpha. It if you see your lectures, it often resembles an area under the Gaussian, that is I am in the rejection zone or behind the rejection zone. So can you plot that? I mean, look at the internet. How do you, I mean, you already know how to plot a Gaussian, how to plot a normal. Find out how can you plot lines, and or how can you fill areas so that you can visualize it. So let me, I think, give you an example of what I mean. Hmm. So can you see the screen? Something like this. So in this case, if you remember our um, Z score was minus 1.8. So at minus 1.8, everything behind this is the rejection zone. That is, if my Z score falls in this range, I will reject the null hypothesis. So can you draw this plot for better understanding? This is also, I mean, if you remember what I was saying, one-sided means the shaded portion is on the smaller side, larger means it is on the larger side, and both means it is on both sides.
What will we keep in x-axis and y-axis in this problem?
In this case, you know how to plot actually at least the blue curve, right?
Hmm, 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 hmm.
So
Blue
the
curve, but
x and
in
y
this,
will
uh, but I don't know like which this like the values, which values I should be taking.
um I mean, you've been in my session in the previous sessions, right?
Hmm, I was there.
So we've done this, right?
Kind of forgotten. I didn't practice after that.
Hmm. So maybe you should use linspace, np.linspace. It will give you, let's say, uniformly distributed values from, let's say, lower value to higher value.
Okay, so the x-axis and y-axis is nothing to do with the previous problem. I just have to make this, right?
Yeah, yeah, because this is the standard normal distribution. It has nothing to do with that thing. Only the
Uh,
shaded portion requires our problem.
okay, okay.
Okay, so let me show you. For people new here, so let's say you have to draw a distribution. So what you do first is you decide on the x values. So in this case, let's say I want values from minus 3, so plus 3, and I want 100 values between them equally spaced. So I can use np.linear space, supply minus 3, 3, and 100. So this gives me x values. Now, corresponding to these x values, I want the values from a normal distributions PDF. Okay. So the way to do it is, let's say stats dot norm. As usual, the location is 0, scale is 1, and you just call PDF and supply the entire array at once. So now you have the x values and the y values. So if we plot it, I mean, we have to import it first. So import matplotlib dot pyplot as plt, import cborn as sns, sns dot set, and np dot, let's say, random dot seed. Let's set it to 0. So we have SNS dot, or not SNS, in fact, plt dot plot. Just give it x and y. Mhm. Yeah, so you get this graph exactly the same as this one. Okay, so now what we want to shade the area, the rejection area. The rejection area is the area less than our z-score. Okay, so for that you use a function plt dot fill. You have to give it the x and y values, so the same as before, x and y. Then you tell it where do you want to color it. In this case, I'll say I want to color it where the z-score, okay, where in fact, let's say where x is less than the z-score, I want to color it. And let's say I want to color it anything. Where plt dot fill, plt dot fill. Oh, it was fill between. Yeah, so make sense. So just a heads up, let's say in future you have to fill multiple areas. Let's say this thing as well as this thing. You cannot do this. Let's say I want that z-score. In this case, I'll say the, for example, something like this. That is, my z-score is minus 2 is x, and let's say 2. This probably, yeah, it will not work. When you supply where, or in case you use an array, you should distribute your conditions into multiple tuples. So you will write this: x is greater than minus 2, x is less than this. This way you can supply multiple conditions. Okay, any confusion? Okay, moving on. So just one last thing. You can compute the same thing using the critical method as well, right? Can you, can anyone answer how can you do that using the critical method? I believe you already have everything you need. It will need just one function call. Any idea? So here's a hint. So in the critical method, um, you just need the area covered when the z-score is alpha. Okay. So let's say in this case, our z-score is minus 1.8. If it was alpha, I would get a different region. That region the value that gives me that region will be my critical point. In this case, alpha was, I mean, a single point. In that case, alpha is an area. So we say what z score gives me area equal to alpha. So can you do that? Let's say alpha remains the same. So alpha is still 0.05. This is area under curve. And let's say you want the critical value. How will you do that? So the CDF gives you the area under the curve. Let's say you already know the area under the curve and you want the inverse. Okay. So to get the inverse, there's a function PPF. Okay. So let's say psi pi dot norm research PPF. Yeah. So percent point function, it's just the inverse of the CDF. Okay. So you give it the area, it will give you the point that returns this area. So all we have to do is the alpha, let's say, remains the same. Critical point is equal to stats dot norm LOC 0, scale is 1, and you say PPF and you supply alpha and you print the critical point. So it says minus 1.6. In this case, let's say our z score is minus 1.8, I believe. Yeah, so just a little bit on the right of this graph. So let's move to problem 2. Problem 2 says a travel blogger. Yeah, do you have a question? Okay, so a travel blogger Y has a blog web page. Over time, she has learned that on average, people spend 20 minutes with a standard deviation of 5 on her page. Okay, she obviously wants to increase this. Now, she she has a white background on her page, and she believes this is the reason. She blames this background for the view time. She decides to replace it with black. Okay. Now she waits a week and collects 100 samples. Okay. So 100 people visit her website and she computes her their basically time on her page. So 100 samples, view time. So we have this data in a CSV file once again. Now, same as before, come up with hypotheses and comment on her intuition. That is it really the white background that changing it leads to a higher viewer time? Okay. Comment on her intuition. You are given that alpha is, let's say again, 0.05, and the standard deviation, I think I've given, yeah, standard deviation of the original population is 5. So let me share this as well. So it's 8:1. Let's wait till maybe 8:10, 8:15. See if you can do that. This time you'll have to do it manually. Yeah. Okay, so for people new here, if you look at the GitHub repository, you'll find the link to the YouTube playlist here in case you want the recordings. In case you only want the code, you'll find it in these folders. So I'll share the link. So is anyone done? It's similar to the last problem. So Ankur, could you do it?
I calculated the z-score, and
Uh-huh.
then I
Correct.
am supposed to get it, match it with the critical value, right?
You don't need to compute the critical value. You can do it with p-value method.
Oh yes, I can do it with p-value.
That would also work if you want to use the critical method. That would also work. In that case, use alpha with the PPF method to get the critical value. Just compare your z-score and the critical value. If you don't use the critical value, convert your z-score into a p-value and then compare it with alpha. Good job.
O- Okay.
Okay, let's start. Let's first of all define our constants. So we have alpha as zero point 0.05. We have uh, the population mean, or let's say the null mean. Uh, let's say population mean, yeah. So we have the mean population as 20. We have our mean sigma as sigma mean impact. That will be 5. And let's get our data. So CSV, we take this URL, we post it here, and we say Header is 0, and we say df dot head. So we only have one column, and that is of type float. So we can just convert it to an numpy array. Okay. So we'll say, let's say time is equal to df dot time dot values, and we can see how it looks. Okay, so we have an array. Um, so the idea is we want to compute the z-score. So since we know the population mean, what have we written? Sigma POP. So since we know this, the z value is very easy to compute. The z value is the mean of the time. So let's say time dot mean. I simply subtract the mean of the population and I divide by mean of the sigma of the population. Sigma of the population, and let's print this z value. Now the z value is 94. So let's visualize this as we did last time. So let's reuse this code. We have this thing. Now notice that if I use x is less or equal to the z score, what do I get? Uh, 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 oh, so I wrote z value. So let's say z score. So you see, we have a very large area. So the point is, the blogger said that she has a mean 20-minute viewer time when the background was white. She changed it to black, and the sample shows us that the time has actually increased. So our null hypothesis is that the mean time remains 20, and our alternate hypothesis is that the mean time is at least this thing. If we print that out, let's say time dot mean, we say that now the alternate hypothesis says that the mean viewership time is at least 24 minutes. When we convert that to z-score, we get this. Okay, so because we are saying at least 24, we actually want the area beyond this point, not the area left of this point. Okay, that would mean at most. We are saying at least. So in this case, when we want to compute the p-value, our p-value, we can't use stats.norm loc is 0, scale is 1, and we call the CDF and we just give it the z-score, because this will give us a very high value. Okay, so what it's doing is this p-value is actually a probability. It's just saying, give me the z-score, I will give you the area from this point to this point. But we don't want that. We want the area on the other side. So what we have to do is we just subtract it. That is 1 minus this thing will give me the actual p-value. And if we print that, we get 0.17. And if we again do this check, so this time we can't reject the null hypothesis, and let's just plot it for our sake. So let's say we have this thing here, and this time we say you should be greater or equal to, or let's say just greater. And we get a plot like this. Does anyone have any confusion with this? So Ankur, was it clear to you?
Yes, I got it.
Okay. Okay, so that's it for today. We only had, I mean, these two questions and their sub parts. So does anyone have any doubt? Otherwise, we'll end the session. For people, yeah, for people new here, let me, yeah, you already have the GitHub link. So all of our previous sessions, the problems that we discuss are present there. So if you go here, data analytics with Python, the problems from previous weeks will be here. And if you scroll down, you'll find the YouTube playlist with the previous sessions here. So does anyone have any questions? Otherwise, I'll end the meeting.
Thanks for the session.
Okay. See you next week. Bye, guys.
Yeah, okay, thanks.